Okay, so here we go. Stewart Cannery is going to package tomato juice in 2-liter cylindrical cans. Find the radius and height of the cans if the cans have a surface area that is less than 1,000 square centimeters. So, here's the can. And I know, because it says in the problem, that the volume of the can is 2,000 cubic centimeters. That is given. How do I find the volume of a cylinder? What is the formula for the volume of a cylinder? I think we've talked about this before, and you knew it. Who can tell me the volume of the cylinder? Pi r squared times the height. So pi r squared h equals 2,000. Now I can't solve that, so I'm just going to hang on to that for a minute, but I know that. The cans have a surface area that is less than 1,000 square centimeters. Well, how do I find the surface area of a can? Now, the surface area of the can means all the surface, so all the paper required to make this. So you got on the bottom a circle and on the top a circle, right? So that's 2 pi r squared. That's the top and the bottom. Now, here are the sides of the cylinder, right? What if I open that up? The sides of the cylinder are really just a rectangle. And the bottom of that rectangle is the circumference of the can. So 2 pi r, and then the height. So the bottom is 2 pi r, it's just the circumference of the circle, and then the height. So I have this less than 1,000. I would love to put this into my calculator and put this into my calculator and figure out where they intersect and figure out where this is below that. I would love to do that, but what's wrong with this equation? It has 2 variables in it. That's not good. So let's come up here for a second. Could I take this equation and get h by itself? And then, could I take this h value and put it in right here? And then my equation wouldn't have 2 variables anymore. It would have just r's. So I'm doing some substitution basically. Got 1 letter by itself and then plugged it in. So is everybody with me on that move? Got h by itself and then took that and put it right here. So now I have this, and this is kind of a mess. Let's see if we can clean it up at all. That, you can't do anything with that, but what's going to happen here? Will the pi's cancel? And will one of the r's cancel? And I can take 2 times 2,000 and get 4,000 over r. Now, let me use our calculators because we're gonna try to figure out what R is. You can do this a couple different ways. We talked about this last time. You can type this as one equation and this as another equation. Now, that is gonna be just a line, 1,000. And I don't know what this is gonna be. I'll just make something, I have no idea what that's gonna look like. Okay, no idea. But let's say that looks like this. This is where they cross, right? You can find that, second calc intercept. Then we want the curve to be below the line. So this would, if I did it this way, this would be the answer to the problem. Would you agree with that? Now, you could also subtract the 1,000 over and graph that as one equation, and then look for wherever it's below the x-axis. So whatever, I'm totally making this picture up, but let's say this is what you got. Then this would be the answer to the question, if you did it that way. All right, so do it one way or the other. I'll do it too. We're gonna come up with an answer. Do it however you like to do it. Please use your pi button. You know where your pi button is. It's over under your clear button. Picture was wrong. I graphed it as two separate equations. So if you are struggling to get it graphed and you're trying to get it graphed as two separate equations, the window I used was 0 to 15 for my x's, and 0 to 1200 for my y's. And I graphed this as one equation and that as one equation, and I got a picture that looked like this. So this will be the answer to the question right here. So I need to find those 2 points. No matter how we did the problem, we should be getting the same answer, so hopefully. Is anybody to the point of getting answers? Was right? Perfect. So my answer, my radius values would be between 4.62 and 9.65. These are my radius values. Now the height values, I can figure out because remember this little equation right here, this thing we substituted? Height is 2,000 divided by pi r squared, and those are my r's. So height is going to range between, by the way, be careful. When you go to type this in on your calculator, put that bottom in parentheses. So 2,000 divided by parentheses, pi times 4.62 squared. So that height's 29.82. 83. And then the other one. So my heights ranged from 6.84 to 29.83. So you could build a can, this one went with this one. So this would be a skinnier can, but a taller can. Or this would be a fatter can, bigger radius, fatter can, and not. In here with boundless enthusiasm, you're all like zonked out now. I managed to put you asleep already. Any question about that before I erase it and we start reviewing? Okay, I don't know if you remember this or not. I'd like to think you do, but before we took our last test, I told you, we reviewed in class one day and I said, okay, we just did everything that's on the test. That was a true statement, okay? I didn't lie to you. We're getting ready to do this thing right here, this page 6, and except for one thing that I'm gonna add, this covers every topic on the test. I'm not saying the problems are exactly the same. I'm saying if you can do this, you can do this test, okay? So here we go. Plow ahead. This is the sheet that up at the top, it says review 262.8 study session. It's kind of cut off, so look at the page number. All right, here we go. We are reviewing, so kind of switch gears now. This is not a can word problem. This is an equation that needs solving. So what do you want to do? Make all the denominators match. So this one needs a 4. This one needs an x minus 3. And this one needs a 4. Would everybody agree with that?
Yep.
I'm not sure you're gonna be able to get all this on here. You might want to use a separate sheet of paper, but that's up to you. Now, once I have all the denominators the same, then what will I do?
7 equal to 0, or, no, cross out the bottom.
Drop out the denominators. So I have 4x plus 20 plus x squared minus 3x equals 12x minus 8. So I'm really just looking at my numerators now. Is that okay with everybody? Now, because it's got an x squared in it, I do want to get it set equal to 0, don't I? Now, how you do that's up to you. You might want to collect like terms first. Whatever, however it works for you. So it looks like I'm gonna have x squared minus 11x plus 28. Double check my work here. Obviously, I did not make this problem up because that, oh, I thought it factored. Oh, it does, 7 and 4. What if it didn't factor? Then I'd use the quadratic formula, right? So we're not alarmed by that, but this one does. So x minus 7, x minus 4, which means the answers to the question are 7 and 4. Beep, 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 beep. Here come the radar. Check it. We have any issues with 7 or 4? Nope. What is the only number we'd have an issue with? 3. We don't have one, so there you go. That's it. Beautiful, beautiful, beautiful. By the way, couldn't you use the quadratic formula on this anyway? Yep. If you prefer that, you absolutely can. All right, now we got a little inequality. What do you want to do with this guy? Always, in an inequality, get a zero. Get a zero. Because you are gonna compare, you're gonna check to see whether things are positive or negative. When you draw your number line and start shading in, so you wanna get a zero. So we're gonna subtract that 5x to the other side. And then what?
Draw a number.
Well, we're gonna use a number line, but I need to put dots on the number line, and the dots are gonna come from the factors. So the first thing I need to do is, how does that factor? X minus 5, beautiful. So now I know exactly where to put my dots. They will be at 0 and 5. They will actually be colored in dots. And now I'm gonna shade somewhere. So I'll just pick a number. 1. 1's fine, 1's in here. So if I put in 1, I get 1 times negative 4. Is 1 times negative 4 less than 0? Yep. So your answer is everything from 0 to 5. Remember, if you don't have any squares, you can alternate. So once I shaded that one, I knew these two weren't going to be shaded, so I'm done. Boy, that seems kind of easy. Anybody have a problem with it?
How do you know if the dots are shaded in again?
Symbol in the problem.
Oh, okay.
If it's or equal to, you color them.
Okay.
All right, here's another inequality. This one is not quite as easy though, but it starts the same way. We have to have a 0. So I am going to subtract that 6. I'm also, at some point, gonna have a number line that has dots on it, just like I did over there. But I have to somehow get to that point, so what do you think? Does anybody remember what I need to do, Lauren?
Get a common denominator.
So this is 6 over 1, so we're going to make the common denominator x minus 1. Now you must keep the denominator, kids. The denominator is going to give you a dot. Do not lose it. You can't get rid of it. You must keep it in this problem. In the equals problems, we don't need to, but in an inequality, we have to keep the denominator. And then the numerator is x plus 2. Watch this carefully. Minus 6x plus 6. So negative 5x plus 8. Did I do that right? So here's my number line, and there are going to be 2 dots on that number line. And I know immediately that one of the dots is going to be at 1. This kind of stuff always makes me nervous. So over to the side, negative 5x plus 8 equals 0. I'm going to figure out where that other dot is by setting it equal to 0 and physically solving it. So I got 8/5. Now some of you can look at that and tell it's just too much for me, so I'm going to write it out. So I have a dot at 1 and a dot at 8/5, which is like 1 3/5. Now, I just got done telling Kendall that when we see this symbol, we color in our dots. with one exception. What is that exception? Denominators can't be included. You guys are staring at me. We talked about this, I'm positive, didn't we? Denominator dots are open because can you let x be 1? Can x ever equal 1? No. So that dot cannot be colored in. This would make me think it should be, but it can't be because x can't equal 1. This one can be colored in, but to not, if you have a dot coming from the denominator of the problem, I don't care what the symbol is, it has to be open because denominators can never equal 0. I'm sorry if we never talked about that before. Does that make sense to you? That it can't ever equal whatever's in the denominator. So that's gonna stay open. All right, pick a number. Here we go. We're gonna shade 0. I like 0. 0 gives me 8 over -1.
Yeah, or no.
Is that bigger than 0? Nope. So I'm not shading that, so I will shade this. And my answer is 1 to 8/5. So just that little section of the number line is the only one that works.
How did you make an alternate on that one? Because there wasn't a square.
If you look at the factors are just, think of, this is like a factor, this is an x value, and this is an x value. They're plain. There's no squared on them. If I had squared here, then I couldn't do that.
Oh, so if they're not squares, you cannot.
If they're not squared, they're regular, and they alternate.
If they are squared, should we just do every one?
You have to do every one. Yep, there's no choice. So, like I tried 0, I would have to try, I don't know, 1.1, and then try 6 or something. Yep.
We can still do it.
You can absolutely still do that. Yep. Yep. You can. That alternating thing is a shortcut. It's a shortcut that always works as long as you don't have squared factors or cube factors or some weird thing going on. All right, we're gonna get one more done before lunch. Here we go, another inequality. Now, when you see that symbol, you think, gotta have a 0, got it, gotta have a number line. We're gonna draw a number line. And the dots on the number line are gonna come from the factors of the problem. So we need to find the factors of the problem. What do you think? What? Grouping? Grouping is a great option, and I want you to think about that. That's a good option. I don't think it's gonna work in this problem. Because if I grouped these two, I would have that. And if I grouped these two, I would have this. What's wrong with that? They don't match. And if they don't match, it doesn't work. So grouping is fast. Do group if it's possible, but what do I do if it's not? Synthetic division. Synthetic division. So here we go. Possibilities will be 1, 2, 4, and 8, plus or minus. So what do you want to try?
-2.
-2. I don't think so. 4? Oh, there we go. There we go. So what does that mean? Now what?
X squared minus X minus.
So what's left is x squared minus x minus 2. Does that factor? Yeah. X
Minus 2.
plus 1? clearly, I'm gonna have a dot at 2 and -1. Where is the other dot? 4. 4. The other dot is at 4. This is the dot. This is the x value. So the dot is at 4, the dot is at 2, and the dot is at -1. What is that third factor? If the dot's at 4, the factor is x minus 4. Kids, this jives completely. If I said divide by x minus 4, wouldn't you put a 4 out here in the box?
Yeah.
Yeah, which is backwards.
Hey, Brogan,
Okay, dots are all open. Who are yellow lanes? Okay, all right, now, quickly, so we can get out of here at lunchtime.
0.
Hit 0, all right? Now 0 is here, so this is where we are checking. So I'm gonna get -2 times 1 times -4. Is that answer less than 0? Okay, what is that answer? 8. Is 8 less than 0? No. So I won't shade there. I will shade this, and not that. So my answer is -infinity to -1, or 2 to 4. All right, we're back at 49. Escape, escape. Back at 49. Have a good one.